Right now I'm in my aquaponics building or my shop, and I've put something together. I'm just showing what I'm doing and talking about a couple new things that I'm going to be doing videos of. I still got a load calculation video, which I'm going to do that in the next week, I promise. I've got a perfect video for that. But let me show you what I've done here. So I've got a mini split here that will run off solar and AC power. And I've basically cut apart the unit so that I can do some training videos on the parts, how it works, maybe the refrigeration system, and basic troubleshooting. You can see right here we've got the terminal block where the power comes in. And then right here we've got a communication board. And this is a communication board from the solar booster to this communication board. This also has the power going through it that feeds the inverter board. So you will have 240 volts going from this board into the main inverter board. Main inverter board is right here, and it's opened up to where you can actually see it. And then over here, we got the little solar booster. And this board really never gets used until we have DC power coming into this board, and this has an MPPT, so it can adjust the power needed for this to run off solar. So I went ahead and cut this out, and then over here you can see we've got a coil and we've got a main board, right? You can actually push this button right here on the board. You can see the Wi-Fi display come on. I have something really cool. Hopefully I'm able to show you this. This is an EEV checker. This thing is so cool. I just had this sent to me this week, and I'm going to be able to use this. Very simple. The person that actually made this sent this to me, and they have a bunch of plugs because some EEV coils have 5 wires, some EEV coils have 6 wires. This particular unit has 5. See right here? We can actually take this plug off of the board, and this goes to our coil. See? There's our coil, and then there's the actual valve. I'll put this back on. This thing is so cool. Watch this. I'll show you how to basically use it. So we can't put this 5 plug connector on these 6 pin connectors, but what we can do is we can use the adapter. And let me get the right one. This one says F6 to M6. That's not it. F6 to M5. This is it. So we take this, plug it in here, boop. And then if we want to test the coil, we plug this in like this, boop. And then what we'll do is we'll push the test coil button. See how it says wait? 5 seconds calculated. And it says ohms. It gives us the ohms of the coil. And it tests the coil, then it gives us an okay if the coil's okay. So I think this is the wrong plug. Let me get the other plug. This is probably the correct plug right here. All right. Anyways, I got this all set up so I can do some more training. This is definitely not the right one. Okay, this was the right one. Let me know if you guys got any questions. I hope you're healthy and happy. All right, plug it in. Badoop. Okay, we can actually open and close the valve, so it's really cool. All right, let's test the coil. I don't know where to get this yet. I don't know how much it costs. See, it says test was okay. Ohms of each coil was 46. And that's what you're going to get for most EEV valves. You're going to get 45, 46. I've also got my PV wires hooked up. So I'm going to be able to hook this to the solar array out back and then go through some testing just to make sure that everything's working correctly. So let's turn it on. Cooling. Hear it? Compressor just kicked on. You can see that accumulator shaking. We got a muffler right here in the discharge line. Some of these mini splits have oil separators, base pan heaters. You know, some of them have reactors. This mini split, the inverter board, controls the switching of the solar to the AC power. So now it's running. Our standing pressure was around 200. So when it comes on, depending on ambient temperatures, we should be around 100, maybe even 115 for our pressure. We're using the high side gauge because we've got our high side hose connected to our 1/4 inch to 5/16 adapter. So let's see what kind of temperatures we get. Let's check our superheat. So yeah, this is basically the setup, guys. See that? I got everything to where you can see it all. And I'm going to be using this just to try to train and teach those who want to learn. And I've got this same model outside, and well, inside and outside. What kind of questions do we got? Let's see what we got. Hi, are you okay? Are you okay? John and Riley, I am. Where do I get one of these? Wayne Hammond. You can go to Signature Solar and you can buy this. And I've got a 12K from my shed and I've got a 24K from my shop. And you can get a discount by using discount code TADDY50. You can get $50 off. Hi, what is the best way to test an inverter board if compressor relay is not opening? Well, I can show you right now in this video. I'll show you guys here in just a second. Let's go ahead and get the meter. All right. So how do we test the inverter board? All right, so let me show you something real quick. Our meter is set to volts AC. If we measure the incoming power, we should have 240. Then that power goes in to our board right here, see? 245. So we can see these two wires, the blue and the brown. What is it?
You meant the EVV.
Oh, I mean the EEV. Oh. No, that's Wayne. Oh, he's talking about the EEV. Where can I buy one? Oh, okay. So, Wayne, I don't know yet. I'm finding all that information out, hopefully today. And within a week, I'll be able to let you know. Sorry about that. I had a miscommunication there. All right, Mick Lee, let me get back to testing. All right. I'll let you know, Wayne. All right, so AC power comes in to this board right here. And then it comes out of this board right here. 245. And it goes into the inverter board, right? All right, so if we have power going into our inverter board, we should have power going out. Where does the power come out? Right here. See this? There was a brown and a blue going in, and then there's a brown and a blue coming out. Now, whenever the power goes out, it's sending 300 volts DC to the indoor inverter board, or PCB or PBA. So we should take our meter and put it on volts DC, and we should go to 1 and 2, and we should have 340 volts, 45 volts DC. Then from 2 to 3, this is our current loop, and we should have DC voltage that's jumping around. All right, so when we go to 2 and 3, see how it's jumping around? All right, that's at 2 and 3. 1 and 2, we had 340, and that's steady voltage. So now let me explain. If you have an inverter board that's getting an input power, but you're not receiving an output power, then your process of elimination has been completed, right? Because we have an input with no output. And typically you're going to see the inverter board's burnt, there's a loose connection, or something internal is bad. This is a very easy way for you to see if the inverter board has failed. Now, if you have inverter board not outputting the correct voltage to the compressor, then you can do a measurement using your meter two ways. One is you can measure the DC voltage, or you can measure the hertz or pulse width modulation. Let's do that. I'm going to do this first, and then I'm going to let you see it. Well, probably safer if I do it down here. All right, I put my meter back up here. We're going to leave it on hertz. See where it says hertz or percentage? All right. Now we're going to take the compressor plug and we're going to plug in black and red. And what's it say? 49%. So that right there is our percentage that we're sending out. Now we should be able to actually check AC power right here. So we're going to switch our meter until it says AC. What's it say? 200 volts AC. Now look where my meter leads are. Be very careful when you're measuring with your meter. Be careful that you don't touch your leads to a piece of metal, or touch your leads to. Just be careful. So there's many ways to check the inverter board. You can check the output power to your fan motor, your compressor. You can just check your output power to your indoor unit. And you can tell because you got an input power, 240 volts to the inverter, and then you don't have an output of 350 volts DC. Now, different manufacturers make their boards differently. Just like their EEV valves. I talked about how some EEV valve coils have 5 wires, like this one. And I think it's made by Sanhua or something. Chinese company. Means like 3 flowers or something. Or it could be made by the other 2 manufacturers that I know of for EEVs. Let me know if you got any questions. And while I'm reading these comments, I'll show you guys some other stuff. Hit the like, fellas. Good knowledge. Thank you very much. Hopefully I answered your question. Looks like the koi fish are ready to eat. This is my aquaponics system. It's a commercial system. And I grow lots of good healthy vegetables, my friends. And actually just germinated some grape seeds. I've got some growing up. I think this is rambutan. And this is an aloe plant. So, and I'll show you in aquaponics, got a big root system. This is deep water culture. Hope you guys like seeing this. I'm going to go ahead and feed the fish while we're waiting for that unit to run a little longer. All right. Hope you guys are healthy and happy. Check out the fish. They hungry. Is that not cool, man? I love this stuff. All right, let me put this food up. All right, let's see. Hit the. Are you pretty busy with work year round? What state are you from? I'm from Tennessee, and yes, super busy. Understood. Great stuff. I have a situation right now. Evaporator fan motor is not turning. How do I pinpoint the problem between the inverter board and the fan motor? Mick Lee, I can help you with that. Give me just a second. Come on. If your fan motor's not running, first you need to turn the power off and then try to use something to spin the blower wheel to see if it's hard to spin. If it's hard to spin, then that's an indication you could have bad bearings. The second thing that you need to do is you need to turn the power off and then take the plug for the indoor fan motor loose from the board. Now you can see that this is my board and that's my motor plug. See? We can measure voltage while it's running, but it's not safe. So I want you to be careful, but I'll go ahead and show you with my meter how you can measure the voltage for that indoor fan motor, that BLDC fan motor. See, that's the plug that goes to the motor. And I've got the motor to where you can see it. Here, I'll go ahead and show you. All right. I'll hold this in my hand. And then I'm going to show you that measuring hertz, we're at about 50%, which was the same speed as the compressor, right? Now let me show you where my meter lead is. It's right there on that plug. See? And we're going from white to red. Now we're going to go from white to yellow. Same thing, about 49%, 50%. Now I'm going to switch my meter to AC. 36 volts, 170. It's kind of jumping around. Let's go to DC, and we really don't have anything. All right. 23 steady volts of AC power between white and red, which is labeled W and V. All right. Now let's put this board back in. And I hope that helps you. Now, there are specific resistance tables that you can actually look at when you're measuring a motor, windings, and you can actually take the power, unplug it, take your plug, and then look at the resistance tables for that specific brand of unit. And the manufacturer usually has resistance tables that you can utilize in reference to figure out if that motor has bad windings or those windings are good. Now, the easiest way for you to figure out if you've got a bad motor is sound. Because most of the time, when you have a bad indoor fan motor, it's going to be making an unusual high-pitched noise. And that's an indication that your motor's bad. Something I've had customers do is they'll try to clean their own wheel, and they'll end up shoving something up in there, and then the wheel breaks to pieces. So yeah, I would check the bearings, measure the voltage. It could be a bad inverter board, or it could be, it could be a bad control board, or it could be a bad motor. Let me know if that helps. Let me know if you enjoyed this. And if you're watching, hit the like button. Thank you so much. All right, what else? Oh yeah, let's check some temperatures. Get my meter. If you guys have not seen my playlist called HVAC Tips for Technicians, I've got over 700 videos on that playlist. Go check it out. All right, now we're going to find our superheat, because when you're charging a mini split, the best way to charge it is to factory charge it, but you can also measure superheat, and you can measure the temperature of the supply air just to see if you've got a 20-degree split or not. All right, here we go. So our pressure is 120, and then our saturation is exactly, looks like 40, and then our Fahrenheit temperature, whoa, I'm getting a weird reading. Let me make sure this is on here correctly. .40 was our saturation. Whoa, I'm getting, why is it jumping around? I don't know what the, man, this is, maybe I got a bad clamp or something. All right, let me move this. Yeah, it looks like I've got a bad clamp or my batteries are low. .26, I don't even know if we can trust that. 14 degrees of superheat. Maybe it's right, so we're close. But something's going on with this. You shouldn't have temperatures jumping all over the place. Oh, no wonder. I don't have good operation. My EEV valve's unplugged. This is super cold. Maybe that 26 was right. Let's plug in the EEV valve. EEV valve is plugged in. You know what? I'm curious though. What if I unplug it? What happens to my supply air temperature? Let me go get my meter real quick. And you know what? We're gonna plug this other one in, or we're gonna turn this other unit on cooling, and see what the difference is between the supply air temperatures with the EEV valve unplugged or with the EEV valve working correctly. You guys go look at the fish. I'll be right back. Okay. All right, I got my tools ready. Who just said poop? Crazy Hunter. What are you doing? Great info, thank you. McLee, you're welcome, my brother. Great stuff. I have a situation right now. This is great info thing. Does the pipe length really affect the recharge pressure, or is it always 120 psi, give or take? Okay, so yes, pipe length always affects the pressure. So you got to make sure that you know what the manufacturer recommends for how many ounces per feet you charge over the certain factory charge. All right, let's measure some supply air temperature. So I've got a dual induct psychrometer, and I'm going to be measuring the supply air temperature here. I'm going to try not to shove this inside the blower wheel. What we got? DJ Carp, it's not necessarily 0.6 because I think Samsung's 0.3, certain manufacturers are 0.2, 0.4. So what we got? 48? Looks like we got what, 48? Show this. So we are measuring this unit, and then we're going to measure that other one that should be the same, but we're going to see the difference between an EEV valve that's unplugged and one that's not. So that's 48 degrees. Now this is the exact same unit in the exact same room. Let's see what we got. $53. Yeah, that's pretty steady. So right now, because the EEV valve is unplugged, right, and it's not metering the refrigerant like it should, we have 4-degree colder air, no wait, 5-degree colder air out of this one. So we're going to plug in that EEV valve and see what happens. Here's our EEV valve coil. That is not the way that goes. Stay tuned, guys. The giveaway is going to end in about 10 days. I'm very excited. It's going to be a great giveaway. I'm giving away $600 this month. Project to Payment sponsoring it. Really appreciate Project to Payment. You're awesome. All right, now, CEV valves plugged back in. You can see the coil sweating. If you don't know how to test sensors, I've got a video where I just showed you how to test sensors, how to take apart the indoor and outdoor unit for EG4 electronics. I got a video on how to identify a bad inverter board. So let me know if you got any questions. Let's see what we got. We are just talking mini splits in Ohio is what we or I go by, or just remove it and weigh it back in. That's a good idea. Just remove it, weigh it back in. Enjoy the channel. You've taught me other ways to doing things. Thank you, sir. Keep up the great content. DJ Cart, thank you, my brother. I really appreciate you. There's our solar booster, our inverter board, our communication PCB. There's our power coming in, power going to our indoor unit. And then I'll be using this for testing just to show you guys how it all works. I will show you my setup outside. See, there's my solar panels connected to my EG4 mini split. Hope you guys enjoyed the little short live. Let me say some closing statements and then I'm out of here. So real quick, if you haven't seen my playlist, HVAC Tips for Technicians, go check it out. Free videos, 700 or more, on how to be a good technician, different situations. If you haven't signed up for the giveaway by clicking the join button and joining, it's only like $2, then you're missing out on a chance every month to win at least $200. This month it's $600, thermal imaging camera, a couple meters, and a couple EMF meters too. So check that out. What else? I think that's it. I hope you guys enjoy the videos. I hope you're going to enjoy the next videos that are coming out. I got the EEV checker, and I will be doing a video on this soon, and I'll be talking about where to get it, which will be really cool. Thank you so much. I'm going to go ahead and shut the unit off. Superheat was what? Oh yeah, we didn't check superheat. Let's check superheat. So project to payment. If you guys have a business, you need a way to have scheduling for your customers, a way to get paid by invoices, or a way to invoice, estimates, send your estimates, or get paid by credit card. Check out project to payment. They're giving away $200, so I like to mention them. Dude, this is everywhere. This meter's got to be messed up, because I'm showing. I'm showing 40 degrees saturation, 23 degrees, 17 degrees, 10 degrees. This can't be right. This meter's all over the place. I need to get another one. Yeah, all over the place. It's either this clamp or it's that meter. I don't think it's the meter though. I think it's the clamp. All right, guys. What we got? Any other comments? Hey, Tad. What's up, Michael Price? Virginia Hernandez. Maybe I am wrong, but I think that you should put on the face to direct the airflow to make a more accurate results. I don't think so, man. I mean, you know, that's just going to restrict the air. But then again, I mean, you're right. I mean, if there is something that's normally here, it's going to be more accurate in the field. Yeah, you're right about that. So very good. I like that comment. Thank you, Virginia. Virginia. All right, guys. Stay healthy, stay happy. All right. This is Tad reminding you, I'll keep you cool if you let me.